Hey guys, Mr. Marabella here, giving you a little help in our Intro to Physics, our math review. I'm looking at our first worksheet where we're practicing some of our algebra skills. Specifically, we're going to look at number 7, which deals with solving a quadratic equation. Now, 9 times out of 10 in physics, when we want to solve an equation that involves a quadratic, we're going to use the quadratic formula. There are times when we'll need to take the square root, and there's a very minute case where we'll end up factoring. Most times in physics, the numbers don't turn out so nice for us, so we rely on the quadratic formula. Okay, so we're going to go ahead and look at our problem. Right, it's d equals vf times t minus 1/2 times a times t squared. Right, we want to find t given, right, that d equals 29, vf equals 25, and vf is just a variable, right, final velocity, and a equals 10. So our first step for these problems, usually to make it easier, we're just going to substitute in the known values. So d is d is 29 equals vf, which is 25, times t minus 1/2 times 10 times t squared. Right, and the reason I'm putting parentheses around everything is so that you can see right, the factors that we're multiplying together. Right, once we start to simplify everything, we can start to drop some more parentheses. So the first thing I'm going to do here in this problem, right, I can do 1/2 times 10. Right, and 25 times t is just going to be 25t. So it looks like this. 29 equals 25 times t minus 5 times t squared. Alright, so probably a lot of you guys are looking at the problem and saying, alright, what do I do here? You might have tried to move the 25t over, right, and maybe divide by t to eliminate 1. That's not going to work for us because there could be an instance where t is 0, right, and we can't divide by 0 in mathematics. So looking at this problem, and a key that's going to clue you in that you need to use the quadratic formula is, right, you have two different powers of the variable you're trying to solve for. So in this case, we have a t to the first power and a t squared. Right? Since the highest power is 2, I know that it's a quadratic equation. And because I see, right, a constant, right, a t to the first power and a t squared, I know that I'm going to rely on using the quadratic formula for this one, which is on your formula sheet. So next step, once I identify that it's a quadratic formula, right, I'm going to move all the terms to one side of the equation, right, and the other side of the equation will be 0. For me, right, I know it's a little bit more work, but I like to move my terms over so that my leading coefficient is positive. So I'm going to add 5t squared to both sides, and I'm going to subtract 25t from both sides. So add 5t squared, subtract 25t, and this is a positive 29. Okay. So my equation is going to end up looking like this. 5 times t squared minus 25 times t plus 29 equals 0. Alright, now I have it set up in quadratic form. Alright, it has to look something like this. Okay, so it'll be your quadratic term first, and your linear term, and your constant term. So to match them up for the quadratic formula, right, a is going to be 5, b is going to be negative 25, and c is going to be positive 29. So I'm going to go ahead and sub them in and solve. Alright, so we got opposite of b plus or minus the square root of b squared minus 4 times a times c. That entire thing, notice I put it over all of it, or all under everything, right? 2a. Okay, so we're going to go ahead and solve here. Okay, so underneath the radical, if we simplify through our calculations, we should end up with 25 plus or minus square root of 45 divided by 10. And now at this point, I can go ahead and calculate. I'm going to get two answers. One is going to be 25 minus the square root of 45, and then I'll divide it by 10. And then the second one will be 25 plus the square root of 45, and we'll divide it by 10. In physics, depending on what value we're solving for, specifically this one, if we were solving for time, we got a negative value. That wouldn't work for us because time can't be negative. If you go through and do the calculations and finalize this out, you should get the following answers. Your small one will be 1.83. Your larger solution would be 3.17. Okay, I hope this helps clear up some stuff for some of you guys. Check out some of the other videos. All right, put another work through example of the quadratic form.